In this video, I'm going to show you the complete process from taking a CAD file to a CNC plasma cut part. We'll be using Fusion360 for our CAM program, and I will also show you the unique challenges that come with using Fusion360 with a floating head.
Hey guys, so the first thing you're going to want to do is download Fusion360. You just search Fusion360, and then here it's this Fusion360 for personal use is the one you're going to want to click on. You're going to want to get started, and you're going to have to create an account and go through this whole process if you haven't already. I already have it downloaded, so I'm not going to go through that process. But some things to keep in mind is with the personal use you are limited. It would be probably a good thing to look at the differences between the paid version and the free version. But the big difference is here. These are the type of files you can export, and these are a bigger deal, the type of files you can import. So if you see here, if you do stuff with SolidWorks, you're actually not able to import a SolidWorks file directly. So like an SLD PRT is not able to import on the free version. You have to either convert it to a step to then edit it on Fusion360. So that's just something to keep in mind with the free version of Fusion360. So before we can do anything with Fusion360, we need to actually export this file as either a step or DXF. Since this file is an assembly, it's just going to be easier to convert it to a step file versus a DXF. You'd have to convert it to a part and then save the faces as a DXF. But so I'm just going to come here, save as, and it doesn't matter what step you do here. Just step, save. Once that's done, you're going to go over to Fusion360 here, and then we're going to want to import that file from the file we just created. So going to go upload, select file, look for that step file, this one. There's a weird bug with Fusion360 where when you do that, it just closes the program, like not closes, but it just minimizes the program. So you just want to have to click it again, and then upload. And this can take some time, and it gets stuck. Like it may just show like half of it, and it gets stuck for a while. Just give it time. It will upload. Just may seem like it's taking longer than it should. Anyways, that actually uploaded pretty quick. So we're gonna close that. So now we have that file in Fusion360, and we're just going to want to open it up. So you have this cube up here that is pretty useful, but you can click here, front, top, but obviously we're going to just want to be dealing with the front with the CNC plasma cutter. One setting I think that you might want to change if you're coming from SolidWorks is if you go here to the profile picture, preferences, I would change this setting that says the pan, zoom, orbit shortcut. It's probably on Fusion360. I would change it to SolidWorks. Apply, OK. That just makes it so when you, like the orbit and the pan is all the same as SolidWorks. Just makes it a little easier coming from the different programs or switching between the programs. OK, now that we have the part imported into Fusion360, we're going to want to create the toolpath for the parts. So we're going to come up here. You can close this. We're going to come up here to the button that says design and we're going to go to manufacture. So the first thing we're going to want to do is create a setup. The setup is basically like what you're cutting the material or what you're cutting these parts out of. So we're going to go setup and come here. And I pretty much just go, you can ignore the machine setup. You can change that to cutting. I don't think it changes much, but the orientation, this is big. So this is where your origin is. For plasma cutting, you normally have that in the bottom left, but see how our Z's the wrong direction? So we're going to actually have to change the orientation. So we're going to say select Z and Y axis. So I'm going to say this is the X, select X and Y axis, and I'm going to say this is the X, and then this is the Y. But see, the Y is going in the wrong direction, so we're going to have to say flip flip Y. So now if we look, the Z's up, Y is that way, X is that way. But it's in the wrong location. It's not. It's in the center of the part. And for plasma cutting, we want that in the bottom left down here. So then we're going to do the origin, say this, and we're going to select that corner right there. So now it's in the bottom left corner. The Z is pointing up, Y is pointing that way, X is pointing that way. So then what we're going to want to do is select the stock. And I just change these to 0 offsets. That just makes it so if you look here, when it was 0.4, it just offsets everything by 0.4, or it was 0.04. But I just do 0, and then I just hit enter, and it says no model selected. You just select all of them, say yes. So now if I go back to here, so we changed the orientation. We also flipped the Y, and then we selected the location for the origin. And then here we just selected all the models. And then we set the stock offset, the side offset to 0s. And then you can ignore this. We'll change it later. So then we'll click OK. Okay, so after we have the setup created, we're going to now need to create the tool path. And so we're going to come up here, 2D profile, since we're doing plasma cutting. So the first thing we're going to need to do is select a tool. And here, I actually have a tool saved, but I'm just going to create a new one because you guys will have to create one. So you want to go here to the plus, and then find plasma cutter. So here, I just left this blank. You can, if you actually are using like a plasma cutter that would have the vendor and all this other stuff, you can input it and get really detailed. But basically the settings that you really need to adjust are this kerf width and the nozzle clearance diameter. So for my plasma cutter, the kerf width, and this is a value you'll just have to look up with your specific machine, but mine is 0.0375 inches, and the nozzle clearance diameter is 0.0625. And that's pretty much the only setting you actually have to change. You can change this cutting data. You can change your default cutting speeds. So you could create a bunch of tools. So you could say plasma cutting tool for 1/8 inch material, or plasma cutter for 1/4 inch, or plasma cutter for 24 gauge, and change these settings here. I just normally change it when in the tool path, and I'll show you where I normally change that, but we'll just leave it at 40. You don't have to change anything here, but so accept, say select. So this material, so after you've selected the tool, now we're going to cut, this is where, see how it defaults to 40? This is where I normally just change it depending on the material thickness that I'm cutting. So what we're cutting is 1/8 inch material. So I'm just I have it that the machine likes to cut at 80 inches per minute. So go with that. Next, we're going to go to the geometry. And so here, we're going to just select all of these. But for example, say you want to just cut the outside and not these the inner holes. You can actually just select the different contours, or say you want to cut 3 of these holes for some reason and not cut the 3rd one. You can do that too. But since I want to cut just this whole part, I can just select the face and it cuts everything. It's just easier than selecting each individual contour. So after we selected all of those, we go to geometry. And here, you're going to want to, since we're probing and using the z-axis, you're going to want to set the top height of your material to, for me, I like to have a cut height of 0.07 inches. And this will be dependent on your specific plasma machine. But I do 0.07 inches. And then don't mess with any of the, and I don't mess with any of the clearance or retract height. But 0.07 for your top height is definitely something you need to change. So after you've set the top height, you're going to want to come to passes. the next tab. The only thing you want to change here is the compensation type, and just change that to in computer. If it's in controller, then the part will be actually slightly undersized because it won't be accounting for the kerf width. And then, yeah, so that's the only thing you need to change there. And then come here, and here you can change the lead ends, but I normally just leave this as the default. So whatever it defaults to. After that, you just want to click OK, and it'll generate the toolpath. But let me show you really quick. If you say you're cutting parts that do have a smaller lead in, or a smaller hole, I'm just going to exaggerate this by like 0.3. So it's way too big of a lead in. See how that's not cutting, and you get a warning here that says one or more passes were discarded due to linking constraints. So that's basically because the lead in is too big. So if you get this warning, you'll want to look, and it's probably, you can change this lead in to a smaller value, and a lot of times that will help. So now it's working because it actually the lead ins are small enough to fit inside the holes. So you can see here that the toolpath is actually generated, and what we can do is we can come here to simulate, and we can actually watch what how it will cut the material out. And you can speed this up just to save some time. After simulating it, you're going to need to now generate the actual G code to give Mach 3. And since we're using a floating head, it's going to get a little more complicated. But for starters, we're going to want to go here and say NC program. So when we're generating when we're doing the post processing, we're going to come here, post, and select edit. So I believe this is searching all of Fusion360's post processors. So I believe if you search Mach 3, this should come up. If it does not, though, if it does not come up, you're going to want to go to the link in description, and then here you're going to want to search Mach 3. And then click download. Then you're going to want to go to, in your Fusion360, you're going to want to go to local and import that file and find the file you just downloaded. And once it's imported, then it should show up if you search Mach 3. So once you have Mach 3 showing up, what we're going to want to do now is click on Mach 3 Plasma, and we have to edit it because the probing on the floating head is it's too fast. And then I also changed some of the defaults to be what I normally use, so then I don't have to change them every time. But so Mach 3, so clicking on the Mach 3 Plasma, we're going to want to go export and just save this wherever and just call it Mach 3 YouTube. So I found it here, Mach 3. You're going to want to open that. So it should just open in Notepad. And basically what you're going to want to do is change some of this code. And what I do here is I go here, the description, I just call it Mach 3 edited. I'm just going to add YouTube so I don't get confused by the two different files. They should be exactly the same, but just so I know the difference. What you're going to want to do next is come down here, and you're going to want to change. So this pierce delay, I just change it to keep it at 1, but the probe offset, this is going to change depending on your floating head exactly, and I'll show you how to get this value. But for me, I have it as negative, and it's always going to be negative 0.25 is what my value is. And then probing, so it defaults to false, and I'm just going to change this to true. And then the z-axis, it says use z-axis. Again, it defaults to false, but I'm going to say true. And then the pierce height is a little strange. So my CNC plasma cutter wants to have a pierce height of 0.18 inches, but I have a cut height of 0.07. So what you're going to do is minus what the CNC says for a pierce height, which for me was 0.18. You're going to minus your cut height from that. So the value I get is 0.11. So that value is just your pierce height that you actually want to pierce at. So for me it was 0.18 inches. Then you want to minus your cut height, which for me was 0.07. So I get the 0.11 for the pierce height. So that's all you're going to change with. Those are the default settings, or changing your settings so you don't have to change those values every time you use this post-processor. So the next thing you're going to need to change is, it's all the way down here under, you're looking for G31. So this function right here, function right G31 is what you're looking for. And what we're going to change here is we're going to change this F value to, so I'm going to delete this, and I'm going to say var F equals F10 and have it in quotes, and actually put a period after this. So var F equals quotes F10 period quotes. And then after, right on this line, the next line down, you want to change this feed output.format.f to just F. So basically, this is your feed rate. So for me, I like it to go down at, because I'm using inches per minute, this is inches per minute. So you may want to change this to something, I don't know the equivalent value in millimeters per minute, but if you are using millimeters per minute, this value will be different. So for me, I have it as go down at a feed rate of 10 inches per minute. So the feed at 10 inches per minute is what it probes at, because it was probing at like 50 inches per minute, which just was way too quick. So change that value, and again, if you're using millimeters per minute, then you will have to change this to the equivalent millimeters per inch, or millimeters per minute. Just a slower value than what it defaults to. So after that, you're just going to have to go File, Save. And so now that it's saved, we're going to go here, Close. Now we're back to Fusion360. We're going to go to Local, and now we're going to want to import that file again, and it's the one we just edited. So now see, the file name is Mach3 YouTube, and the description is Mach3 Plasma Edited YouTube. So we're going to select that post-processor. Here, we're going to change the file name to just YouTube test, or I guess example. And the output folder, you can select where it's going to save. I'm going to have it save it here, select folder. And then here, so you can see now it's populated these values. So you can ignore this stuff, the group 0 and group of 1, but general. So your pierce delay is how long. I know it says specifies the delay in pierce in seconds. I have mine, for some reason mine actually is milliseconds. So for 1/8 inch, I want to delay 100 milliseconds. So then the pierce height, see how it just autofills this 0.11. Also probe was checked, and the probe offset is negative 0.25. Just make sure those are the values that you specified in the code, and then use z-axis is also selected. So after those are all good, we're going to want, and really quick, your pierce delay depends on the material thickness, and you're going to want it, that changes depending on the machine you're actually using, and this is a value that you should be able to just look up. So after all these are set, we want to say okay. And so now it created this NC program. And say we want to edit this for some reason. You actually have to come up here and right click and say edit. So now we have access to this. So, but we want to post it. So we're going to say post. So here, and then say view, and it pulls up the actual G code here. And I just quickly check and say this G31 line. So it's Z -100, that's correct. F10, that's correct. And a Z offset, this N92, the offset is -0.25. And then it goes to a Z at a pierce height of 0.18, that's correct. And then it triggers the torch, waits 100 milliseconds, and then it goes to a cut height of 0.07 at a feed rate of 80. And this is the cutting of that piece. So I just double, the values I check is make sure the offset is correct. I make sure the feed down for the probing is correct, as well as the pierce height of 0.18 and the cut height of 0.07. So it looks good. So that file was saved in the folder. So after we post, so you have the file right here. And so that's actually it. So now what we're going to want to do is come here and find the USB drive, the thumb drive that you're going to use for your plasma cutter, and just drag that file over. So now it's on that USB thumb drive. And then we'll go over to the plasma cutter and cut it from there. So really quickly, I'm going to show you how you find your probe offset. You're going to want to come to your diagnostic screen. And if you'll notice here, when I trigger the limit switch, the digitizer light comes on. So what you're going to want to do is place a piece of metal under the torch and slowly go down. And then using the control, you just want to go down slowly until the digitizer light comes on. So it just came on there. Now what we're going to want to do is come back to the program run. So 0 to Z. And then what you're going to want to do is go up until till the floating head is just barely touching the metal. So you can see here that I get the 0.25. So that is your probe offset. So what I'm going to do first is just input the USB into the computer. And hit cancel here. And then I am going to home the plasma cutter. So I'm going to home it by clicking Ref All Home. So now all of these right here are green, so it's all referenced. So I want to cut the part right here. So I'm going to line it up where it just barely cuts up to this point and then goes over. So I need to first zero the, find the origin and zero that somewhere over here. So the way I'm going to do that is first by loading the part. Once the part's loaded, I'm going to go to the corner and kind of roughly where I think it is, but I'm going to zero the Y this direction first. So zero the Y, and then I'm going to go up to the top right here,
the top. And then I'm gonna zero the X on that corner. So zero the X. So now if I go back, you can see I can go around the whole part and it's gonna cut out and not go off the edge there. So once it's zeroed, X and Y, now we're good to start cutting. So after making sure your ground clamp is connected and everything looks okay, you click Start Cycle. Thanks for watching. Let me know if you have any questions in the comment section below.